Welcome to 49cc Scoot. My name's Brent, and today I'm going to be doing a little bit of port matching and maybe some smoothing of the cases for the RC1. Before I get into port matching, I wanted to mention that in the last video I was doing a bunch of pre-assembly measurements, which included cylinder bore, piston diameter, and then checking the piston to cylinder clearance. And in that I found that my clearance was higher than I wanted. It was 3 to 3.5 thousandths of an inch, where Malossi was specifying around 2 thousandths of an inch, or basically 0.05 millimeters. So I went out and bought another piston, and it just came in today. Unfortunately, when I unboxed it, it turned out to be a 0. It was just listed as a replacement piston for the Testarossa kit, but it turned out to be a 0 instead of an A piston, which should be a little bit smaller, but I measured it anyway, hoping it may tell me something. This 0 marked piston came out to 2.0441 inches, so 3/10,000ths of an inch smaller than my A marked piston that I already thought was too small. In metric, that rounds off to 51.920 millimeters. My last piston came out to 51.928, but we might as well just round that up to 51.93 because I don't have the accuracy to expect that I'm going to get that close every time. An A piston would usually be the standard piston, and then normally you would just go up A, B, C, D. B would be 0.01 millimeters larger, C would be 0.01 millimeters larger than B, and so on. In Malossi's case, they also offer a 0 piston, which should be 0.01 millimeters smaller than the A. And again, if we round this up, that's what my numbers come out to. The 0 is 51.92 and the A is 51.93. So it looks like there's not a problem with my piston. I thought perhaps I had a piston that was manufactured too small, but based on these measurements, I'd guess that's not the case. However, I'm not really sure how Malossi is coming up with 2 thousandths of an inch or 0.05 millimeters of clearance when pistons are running these numbers. I'd also like to point out that if you look at the crown of this 0 piston, you can see that it's got a bunch of machining marks in it. They're very obvious near the edge where it's shiny, but they go all the way across the piston crown. How much difference does this actually make for most of us? I would say practically none. You can get into discussions about surface roughness on piston crowns and find various opinions, but in the real world, if you were to ride with this piston, which is sort of poorly finished, although it's not rough cast like a lot of pistons I've seen, versus something that's polished or nice and smooth, even like the A piston that I have that came standard with the cylinder, you wouldn't notice the difference. Maybe somewhere down the road you would notice a difference in the carbon buildup, but unless you were dyno tuning it and to a very fine accuracy, I don't think you'd tell the difference either way. For me, this is mostly about quality control. So this is right up there with when you saw my unboxing video, chips of metal left over on different parts of the engine, on the cylinder head and things like that. This is kind of the same lines. It's just sort of disappointing for such a high-level engine from a high-level company. This is supposed to be top-notch stuff, so I'd just love to see a lot more consistency than having these machining marks all the way across the crown of one piston and then the other one is smooth. So anyway, with that said, I just wanted to point it out, just trying to give you the full experience of what I'm seeing here, and now we can go on to the porting. Since the RC1 is sold as a package and the cases are meant to be paired with a cylinder, I would expect that the cases and the cylinder should match up very well. However, I've seen other people post that that is not the case, so I definitely want to check this out. What a lot of people do when they want to port match the base of their cylinder to their engine cases is use the base gaskets, and they basically will just take one of the base gaskets, attach it to the engine, put it on the studs, and then mark where it is not aligning. However, before you do that, I always suggest that you make sure that your base gaskets actually match the cylinder, because sometimes gaskets that come with the cylinders aren't really a good match for them. So that's going to be the first step for me. This cylinder kit comes with a bunch of different gaskets in different thicknesses to allow you to set the squish properly. So you would assume that these should all match, but before I do anything, I want to make sure that all of the gaskets match each other. That way I know that whatever I'm working with is going to be correct. So just holding these two to each other, they look to be spot on. Do the same thing with the next two. They look good. They look good. Alright, so at least we're all good there. I know that if the gasket matches the cylinder, at least all the gaskets match each other, so I'm not going to be off that way. I'll use the thickest gasket just because it's a little bit easier to work with without bending. And I'm going to go ahead and see how that looks. So what I'm going to do is put the studs through here just to help me hold this in place a little bit. With the studs in place, I can see that there is still some movement of the gasket. I was kind of hoping that Malossi would have designed this where this section here, the unthreaded part in the center of the stud, was large enough that it prevented all motion, essentially. That said, this really isn't a lot of movement. I've certainly seen a lot worse, but with a race engine like this kind of platform, it would have been a great opportunity for them to have some studs where everything was totally stationary. But that said, you can kind of push this gasket in because of the way it's formed and get it to center how it wants to be anyhow. So you can see here, you got mismatch here, mismatch here. Again, the boost port looks pretty close, and then mismatch over here, mismatch over here. Now this being the water port, it's kind of up to you if you're really going to worry about that, because this isn't going to be a horsepower thing, but it may help the flow of water a little bit if this were all matched up perfectly. You'll find that people have their own preferred methods for doing markings like this. Some people would like to remove the gasket, mark this whole surface with layout fluid or machinist dye. Then they would take the gasket, put it back over there, and they would use a scribing tool and scribe marks into there. That works very well. You can do the same thing essentially with a Sharpie. You can just go across and mark the surface that way and then scribe lines in there. Or a lot of times all I do is I put this on, get it nicely centered. In this case, I think having the studs isn't really of any benefit to me, because if you set the gasket on this way, you can see it's kind of raised here, and that will help it center right in around those holes. And you can also visually look in there and make sure everything is well centered before you start. And then just take the Sharpie and mark anywhere that there's a mismatch. And it's not a big deal to put Sharpie onto this gasket. You can easily clean that off. No markings around the boost port, all that looks good. Again, if anything, it may be that the gasket could be slightly smaller than the boost port. I may check that more thoroughly later. Most of it is just right here. There's a thin line on the top of each one of the transfers, and then a thin line on the bottom of each one of the transfers that should be matched up. Taking a really close look at the boost port, it does appear that the gasket is going to hang over into the boost port just a tiny, tiny bit. I want to file that so I can be sure that my gasket does match up when I put it up against the cases. So I'm going to start by just lightly tightening one of these studs down. Then I can go around and check all the little holes here, make sure everything is aligned as well as I can get it. Then I'll go ahead and put a second stud in over here. Alright, so before I tighten that up too much, I'll just look at the other side again, make sure everything is centered. Go ahead and snug them down. And snug them down, you can see I'm just using my fingers. I just need enough that it's not going to move around. I'm not really trying to torque them. I'll go ahead and just file this edge gently. Now I'm just going to take my angled scribe, and I can go across there, and I can see that this is no longer hanging up on my gasket, at least not on the straight edge. I might need to do just a little bit in the corner with a rounded file. And this is really light, gentle filing. It doesn't take a lot because this is very thin material. I'm just going to use my scribing tool again and go over that corner and just see if it's catching, which now it's not. So that corner looks good. Now I'll just need to do the same thing over here on this side. I'm satisfied with the match here around the boost port, so I'm going to remove this. And then because the files are so rough, I've just got a piece of a Scotch-Brite sander here, and I'm just going to go right over the edge of it this way, just to try and make sure I take off any really rough debris there. Not really sanding it, just knocking off any loose debris. I'm getting ready to start working on my transfers, so I've got this clamped in a vise, not too tight, enough that it's not going anywhere. And I've got it at an angle, that way when I'm trying to work on it, it's a good viewing angle for me, and it's a good angle for me to get the rotary tool in there. I've got a whole selection of burrs that I could use for this, but because it's so narrow when you start getting close to the cylinder, I think I'm going to stick with the smaller of the burrs. And basically what I do is pick out something that I think is going to work. I know I want something tapered, and I'd prefer a single cut for aluminum. So perhaps this bit. And then you can just kind of hold it and see how you think it would go in there, if it's going to work for you or not. And of course, don't forget your safety glasses before you actually start grinding. I went really close to that line, tried to leave just a small portion of that all the way across, and I blended it in there a little bit because I'm not taking out much, there's not a whole lot of blending there. And now I just want to finish it off with a file. The reason I'm going to go with a file right here is because I can do a better job of providing a nice straight edge there. And for the finishing touch on that area, I'm going to wrap a piece of sandpaper around my file, and that'll let me do a little bit finer finish on that. The blending looks pretty good to me. It's got a nice straight edge there. It feels pretty good. Just for a double check, I'm going to take this scriber with the angled end and I'll run across it and make sure that I can't feel the angle changing there. If it does, then you may want to get in there and sand it a little more. Before I move on from that little section, I'll take my gasket, make sure I've got it properly installed and seated where it should be, and then take a close look at that edge and see how it looks and feels, and everything is good there. Now I just need to repeat the process for all the other areas that I've got marked. I'll flip the cylinder over in my vise before I start up here because to me it's a whole lot easier to get to that when I can look kind of down on it this way versus trying to work up this way. Everything looks good to me now. Got nice matches on all the spots where they were previously mismatched. And the only thing that I may do from here is to take some of this 120 grit, wrap that around my file, and just quickly rough up those areas because the areas where I've just filed with 320 grit are so much more smooth than the rest of the port. While the cylinder's right up here, I'm going to go ahead and bolt up my exhaust flange and see how well that matches. And by the way, when you're bolting up the flange on this, you see that he's got these spring holes at the top for your exhaust retaining springs. They should always face toward the top of the cylinder or toward the deck. There's a little bit of play allowed by the bolt holes, and if you get it just right, if you're paying attention when you bolt this up, it's really close to matching. So I'm going to go ahead and bolt it down here, which is the closest I can get it, and just snug it down. And at this point, it doesn't feel like there's a whole lot that needs to be done. You could probably just leave it alone because it's very minor. But there's a little bit of a mismatch here, just very slight. You can see most of the way around, it's not even snagging. There's a little bit of a mismatch just on this edge. Again, really slight. Tops and bottoms are pretty good. There's something incredibly minor here. But yeah, it's basically just a couple of spots. I switched over to a little bit wider and a little bit longer burr. That way it makes it slightly easier to get in there. And this should take very, very little work just to try and totally match those up to each other. That required barely any effort, and now this is almost a perfect match all the way around. So props to Melosi for that, although I will say this is more on the level of what I'd expect through their entire kit for mating surfaces. Now to finish off my work on the cylinder, I'm going to remove this flange, and then I will take the flange and the cylinder inside, and I will wash those very thoroughly with soap and water, because I want to get all of the metal particles and all of the sandpaper bits and all of that stuff out of there. Then I'll come out and dry them off with compressed air, and I'll make sure I go through every bolt hole passage, etc. Again, I want to get all that crud out of there. The next step is going to be port matching the cases to the gasket, which you can see even with a quick and dirty match up here, there's quite a bit of difference there. But before I can even get started on that, I was going to install the studs so that I could hold that gasket up against there, and I noticed that the studs don't really want to start, at least some of them don't. And that's something that I saw also when I was using the studs to secure the gasket to the cylinder. A couple of them didn't want to allow me to start the nuts on there. So I don't really want to force studs into the block. So what I'm going to do is I have a die and a tap here. Unfortunately, I don't have the actual chasing type that aren't quite as aggressive. These are just a regular tap and die. But I'm going to run those over the studs and gently through the cases real quick. What I've seen with most of the studs is that one side will start a nut on there okay and the other probably won't. So what I do to hold this in place so that I can run that die across it is install one nut kind of upside down, as you see, and then you butt another one up against it. You can use 2 wrenches and just snug those up to each other. And then that would allow you to put a wrench on there to hold it. That way you can run the die across there, or you could possibly even put this in a vise. While I'm hoping this isn't a very aggressive action, I'm going to start with a drop or so of thread cutting oil, or maybe much more than I intended. Now I'll see if I can get the die started over that, and I'm going to start it by hand because I don't want to force this on there with a tool. I'm really hoping it doesn't take a whole lot of effort to straighten these out so that they'll work well. It's going on a bit, so I'm just going to switch to a socket to make it a lot easier. Now I'm going to use a blast of compressed air. I hold a paper towel here just so I don't blow any of that leftover oil anywhere. Try to clean them off a bit. Quick shot of parts cleaner. And one more dose of compressed air. And I've got one of the nuts here that I've already used and I know seemed to work fine before, so let's just see if this will go on here now, because before it didn't want to start. There we go, now it actually works. And for the cases, again, a drop of thread cutting oil right in the threads there. Make sure your tap is clean before you start. You don't want to introduce any chips with the tap. And then just very, very carefully get that started. Don't put a bunch of pressure on it. Don't use a holding tool to get it started. Just work with it until you're sure you've got that straight and it's going in the way it should. Try to work that by hand what I can, which is apparently not much. Clear some chips, and then redo the process. This time I'm actually going to use my tool. Thankfully it's not taking much pressure. This is going through there pretty easily. It's bottomed out. I'm just going to bottom it out very lightly. And Now I can back this out. I've definitely got a few chips on there. I'm going to blow out the threads here. Squirt a little bit of parts cleaner in there. And then once again, blow this out. And by the way, make sure you got safety glasses on. You don't need chips or parts cleaner in your eyes. That's much better. Now the stud actually goes in there. And it's not loose, but it takes a minimal amount of effort. So again, same deal, just repeat the process all the way around. Now that the studs are in place, I should be able to put my gasket on here and then do my port matching, right? Well, not exactly, because the holes in this gasket are a little over 8 millimeters and the studs are 7 millimeters, so you can see how much play there is there. My first thought was that I have these 7 millimeter to 8 millimeter dowels, and I could just put those over there. They fit fairly nicely, and then I could put the base gasket over top of those, and that would eliminate a lot of play, which it does take quite a bit of it out of there. However, when I try to push the gasket down, it seems to just push these dowels up, and I'd like it to actually stay in place. So what I'm going to do is take that dowel, and I'm going to carefully align the edge of my masking tape with one edge of it and wrap that around there. Then I can slide that on into place, push it all the way up against there, and then just push the masking tape down onto the stud so it'll stay there. Pushing it all the way up in there as far as it'll go. And now you can see I got a nice tight fit. That thing is not going anywhere. That really is quite a mismatch in all of the port areas. So you can see here where the cylinder skirts would go, in all those areas, it's really tight. But in all the areas where there's actually flow, those are way off. Then down here for the water port, that's nearly a mile away. I'm definitely not going to worry about trying to raise that up until it's all the way up there. I would rather have that material, I think. I'm going to mark this the exact same way that I did the cylinder, just using a permanent marker. And even though I'm not going to match this, just so we can see it, I'm going to go ahead and mark this water port as well. There's what we're looking at for mismatch, and it's pretty substantial. Just out of curiosity, try to take a rough measurement up here. I don't want to scratch it all up. That's about 3 millimeters of mismatch up here at the top of the boost port. Probably about 2.5 here on the sides, maybe 3 in this area. Yeah, so 2.5, 3 millimeters of mismatch in all the port areas. So hopefully you enjoy removing material. In the boost port areas, my main concern is just removing material and keeping nice straight edges there, making sure it matches. In this area, it's kind of the same. Any of it you want to blend in. You don't just want to take it right off the edge and have it scoop up all of a sudden. So you want to blend it down in there. Like the boost port, I may try to go all the way across or create a curve up there. Here, this is a lot, almost 3 millimeters, and they have this nice curve here that's going down into the rest of the cases, and I'd like to maintain that. So this area I'll probably work all the way down to some degree, and I'm going to take out all these little casting flaws, these parting marks or casting marks that are in here while I'm at it. There's also a little ramp here that's kind of steep. I may try to blend that a little better. I doubt that I'll do very much because I don't know how thick these cases are and I don't want to have to backfill and break through and all that stuff. And on this edge of the transfer, I'll probably create a little bit of a radius there. Again, just trying to smooth flow the best that I can in there up toward the transfer. This is the burr that I've chosen to start with. Just like when I was matching the cylinder, I would suggest that you take a few test runs without the tool on and see how it fits in there and exactly what angles you want to approach at. It's going to change as you go on because this is a pretty big job to remove this much material, but at least get an idea of what you're doing before you start. It may save you some headaches in the future. Also, be very attentive. It's incredibly easy to take off more material than you intended to, or to take off material in the wrong way than you intended, and you can't really put it back too easily. You could go in there with filler, but trust me, it's much easier to try to do it right the first time and not have to deal with all that stuff. And also, wear your safety gear, safety glasses, and you're going to be making a whole lot of chips. If you're making some fine dust with the aluminum, it might be a good idea to wear a mask or a respirator as well. It's really important to stop every now and then, clean out the chips, and then see how it feels. Because sometimes it may look okay, but maybe when you run a finger or a thumb across there, you'll feel a little lump that's not very smooth, so you know you got to go back and pay attention to that area. I finished most of the port work with the carbide burrs, but I left a little bit of a thin edge right around the areas that I'm going to port match. That way I can still get in there with a sander and probably some files at the end and make sure I've got nice edges there, but I want to try to create a little bit more uniform surface across these areas. I just finished up roughing all this area up with some 80 grit, and I thought I was about done, but I'm checking with my base gasket to be sure. And it looks like I've got just a little bit left over here, mostly the corner, maybe a little bit there, and a very, very tiny piece of this corner. So I'll go ahead and mark those one more time and try to get this wrapped up. This looks good to me now, so I'm going to go ahead and remove the gasket and the studs, and then I'll take the case half in and thoroughly wash that, and then come out and use compressed air to dry everything out and blow out all the bolt holes, etc. Now that this is clean, I'm going to do one final check, and this should turn out alright as long as everything has been aligned properly through the process. So I've got the studs in place. I'm going to go ahead and put the gasket on, and then I'm going to slide the cylinder in place. And I'll go ahead and at least start a couple of nuts on there so I don't drop the cylinder. Once everything's assembled, then you can look through the cases up into the transfer ports and into the boost port, and you can examine all those edges and how well they meet up and see if there's any adjustments that you need to make. The large case half is a little bit more difficult to support in the vise, so I'm just going to work on this right on top of the workbench, and it's the same process as the other case half. I put the cases back together because I've already checked each individual case half and they align well with the gasket, but I wanted to check the two cases together. One sign that you're off somewhere, even if it looks okay with a gasket, is if you put these two together and this boost port line, the very top line, isn't straight, or you feel a bunch of difference between the two, something's gone wrong. But in this case, it actually is very smooth. You can also run your finger through there and feel the transition that goes up toward your reed cage and make sure everything is matched up pretty well there. If you've taken any material off inside of there, you could have a mismatch, so you may want to correct that. And then I'm going to put this thing back together with the gasket, and we'll just double check it that way. I only installed 2 studs because I had unwrapped the others, and these are very tight to those stud holes, so they should work fine, and everything still looks good. So that should conclude my port matching for the cylinder, the cases, and the gasket. If you want to give it a really thorough inspection or see if you can take it a step further, then I would advise bolting up your cylinder like this. Just put 2 studs in, and then you can see everything that's going on in there, and you can evaluate how everything would move around and decide if there's any other modification that you'd like to make. For me, one of the things that sticks out is these cylinder skirts here have very, very sharp edges on them, and I'd kind of like to knock those sharp edges off. However, this is a plated cylinder, and it does get dark all the way up to the edge, so I'm thinking maybe the plating material goes all the way up to there. I believe I'd be fine to dull them out, knock that down a little bit, but I'm probably going to leave it alone because I think you'd be talking about a small fraction of horsepower there, if anything, and this is going to be, even though it's a race motor, I will be driving it on the street, so I think I'd rather just leave that alone and not risk that I damage the coating, get a chip started anywhere in there. But that's your call. Look through there, do your research on porting, and see if there's anything else you want to do. I did see something interesting when I installed the piston, so let me show you that. I'm going to slide the piston in there, arrow facing the exhaust port, just like it normally should. And I'm going to push this piston down until the crown is just below the port floors, or just flush with the port floors. So at this point, it is sitting exactly flush with the bottoms of the transfers. It's a little above the floor of the exhaust. But look at where the piston sits in the case. So I would assume this is where the piston would be at bottom dead center. I can't tell for sure without the crank, but usually the piston will be about flush with the bottoms of the transfers. So let me move the piston out of the way. And you can see we've got sort of a two-step cutout here. A large cutout for the cylinder skirts, and then a little smaller cutout that appears to be clearance for the piston. But the problem is, while I don't have a base gasket in here, and the base gasket would add some height above it, I don't see any reason why they would want to cut this so that the piston is that close. So let's say I use a 1/2 millimeter base gasket. That means the piston would be a 1/2 millimeter away from this once I added the base gasket in. But why does it need to be that close? I see no reason. And this is the other case half, the smaller half, and it's the exact same scenario with the piston where I would assume bottom dead center would be, or close to it. It's right up against that cut in the case. I happen to have a pair of what I call dummy bearings here. Maybe you call them mock-up bearings. Basically, these are stock bearings. These happen to be for a Minarelli is what I first made them for, but it turns out they fit this. So they're stock bearings, standard bearings, whatever. And all I've done is sanded the inside of each one and the outside of each one. And what that allows me to do is to slip them right onto a crankshaft like that. I don't have to press it on. It's a fairly snug fit, but it'll go on and off easily. And they will also slide into a crankcase. So because of that, you can easily, quickly mock up an engine if you want to check something like this, for example. So I'm going to go ahead and put this together as a mock-up, and then I'll be able to actually see where bottom dead center is. I'm not going to bother with piston rings and circlips and such, but you do need to fit the bearing just so you've got the proper amount of clearance there. Otherwise, there will be a bunch of slop and play in the piston. And you can oil the piston if you like. I may do another check while I'm at it where I wouldn't want oil on the piston. So I'm just going to go ahead and slide this in there. I'm not going to be rotating the engine around a whole bunch. I'm also not going to torque the cylinder. In fact, I'm not even going to bother to put all 4 nuts on there, because 2 should be sufficient for what I'm doing. I'm not looking for the exact amount of clearance that it has down to the 1/10 of a millimeter. I just want to see pretty much what's going on here. Now I'm just going to rotate the engine around until the piston is at bottom dead center. And if you're not aware of what bottom dead center is, it's really simple. It's basically just the lowest point in the stroke, or the point where the piston is at the lowest point in the bore. Bottom dead center appears to be right there. And that is higher than I anticipated bottom dead center being, because there's about maybe a millimeter before the piston crown would be flush with the floors of the transfers. I thought it would be flush with them because generally that's done that way you can get great cooling effect and it doesn't block the ports off at all. But it looks like in this case it's always going to block them, because if I'm a millimeter off there and the thickest gasket is around a 1/2 millimeter, it just can't get there. Now we're looking in through the top of the engine where the reed block would be. You can see the pistons moving up and down there, and the connecting rod and the crankshaft is in the view. So this is bottom dead center, around there about the bottom of travel. And there is actually some clearance there as it's set up, and you could add the thickness of a base gasket. So I guess it was a false alarm. It appears that it should actually have clearance, but man, that looked really close on an initial check. I was curious to find out what the actual clearance is down there, so I had this strange idea to do some sort of reverse squish check at the bottom of the piston. Took a piece of solder and laid it across there, and then tried to rotate the engine over, but it basically just wanted to push the solder out of the way, and I couldn't really get an accurate result, and I didn't want to stress the engine out too much. So I guess I'm going to resort to the old-fashioned way. Got some feeler gauges out here. what I'm doing is basically taking these two feeler gauges and I'm laying them right on top of the ledge, and then I'm moving the piston down on top of them. So this currently, I've moved down a little. This is a 20 and a 19 thousandth, so this is just shy of a millimeter. And I can put that on the ledge, push the piston down, and that's grabbing my feeler gauges. So the up and down play you're seeing now is just the play and the little dial, the pivot point here on the feeler gauge, but it's actually got a hold of the feeler gauges. So I would say there's less than a millimeter there. I don't see any point of being too exact with all of these because, again, it's kind of a tough process, but I'd say there's less than a millimeter of clearance between the bottom of that piston and the case where it's cut. Even though I think this will be fine with a little under a millimeter of clearance, because that would definitely be an acceptable squish clearance if it was anywhere near a millimeter, I still think I'm going to go ahead and cut it because it's really not that difficult, and I don't think there's any great consequence. There will be a great benefit if the piston never hits a ledge in here, no matter what setup I put on here, but there's really no consequence aside from maybe some small amount of case volume if I just extend this down a tiny little bit. I could try to set up a case cutter. I have a Mineralian GY6 case cutter that's made for making this bore here, but it wouldn't bolt up to this case. It's not going to be worth me spending the time trying to come up with some adapter to make it work, because I don't think this is very difficult. On both cases, it's essentially the same. You can see there's not a whole lot of area here. It should be fine to do with just a carbide burr, just obviously being careful of the sealing surface up here, and of course you don't want to get wild and cut too deep in there. That took less than 5 minutes, and now instead of the piston having to stop about there, it's got another 2 or 3 millimeters, so it can go all the way down to there. That should be well more than is ever necessary, because now you can see the piston is actually a couple millimeters below the transfer ports. Now that that's done, I've got this mocked up again. Piston and the crank are in there because I want to be able to look into the exhaust port and see the piston. Here's a closer look, and you can see the piston uncovers and then recovers the exhaust port. Now what I want to do is get that piston all the way up to top dead center. So like I explained, bottom dead center is the very bottom of the travel, top dead center is the very top of the piston's travel. Then what I want to do is use a marker, or sometimes a pencil will work. I'm going to try it first, and mark the piston so that I can see where the piston is coming in contact with the exhaust port. And I'll explain that in a second. But you've got to make sure you're holding this at top dead center when you do it. And then simple enough, just get as close to the edges as you can. Mark all the way around there to each corner. You don't really need to worry about the center section too much. You don't have to mark the divider in there. And you can see even in the bottom of my camera shot here, I'm not getting right to the edge, so I need to keep that in mind, because just the way the pencil is, it's not putting the mark all the way on the very edge of the port. So I've got to remember I've got maybe a millimeter around that marking. After I got this out of there, I did go around it with a marker. It'll make it easier to see, but also, as I told you, I was probably around a millimeter or so from the edges. So I made this a little bit wider when I did the marking on there with a marker. And that way it should give me a little bit of a safety region there. Now, why am I doing this? The reason is because this piston has a lot of sharp edges. On the inside here, they do a pretty good job of rounding everything off, but then on the outside edges, like all of this area, all around here at the bottom of the skirt, it's fairly sharp. They did put a very, very mild chamfer, and I don't even want to call it that, but it's at least not incredibly sharp right here on this edge, and well, it's fairly sharp here and here, but all of these edges especially, anywhere there's a window cut into the piston, all of those are very sharp. So these will actually align with your transfer ports. The ones on the sides are going to align with the transfers. And then this aligns with the boost port. Now, this is smaller than the boost port is. I can show you real quick. It doesn't actually match up with the boost port totally. You could try to match it, but there's really not a lot of piston here. If you tried to match that and then also went over here and matched up the transfers on the sides, you'd essentially have nothing left over here for these little pieces. They'd be very thin, and I don't want to risk the piston breaking or something, and I don't want to remove that much support. So I don't think I'm going to go that far and try to match all these things up, but I would really like to at least knock off the sharp edges in here. So with that said, still, why did I need to do this? Well, one time with a 49cc piston, I tried to really round all this stuff off, make a nice kind of airfoil shape that curved all the way around here. And to do that, because of the way these things kind of taper out this way, you end up taking a lot off of here if you really create a lot of a rounded edge. And when I did that, I got all the way up so close that the exhaust port was actually uncovered a little bit by the piston when it was at top dead center or even below top dead center a bit. And that caused some problems with basically the crankcase being connected to the exhaust port, and it wasn't good and performance suffered greatly. Just a little bit of work to try and improve things made things go downhill. So I don't ever want to do that again if possible, and that's why you do checks like this. So I know if I wanted to soften up the bottom edge here, I've got very, very little room to work, so I'm not going to put a whole lot on there. I may just quickly sand this and just create a little bit of an edge, sand file, whatever. Over here, I do have a little bit more play, but I'm still not going to do very much. I'm just going to lightly chamfer this, just try to take off the very sharpest of the edge. I'm not going to worry about really rounding it out because there's just not enough room there that I want to play with it that much. I should also mention why you would want to do this, and that is because these very sharp edges, number one, when you're talking about especially thrust surfaces like this, the sharp edge can tend to scrape off oil. It doesn't carry it as well as it can, and some people say, well, all the oil should be carried within the honing of the cylinder, the texture of the actual cylinder bore, but it can still kind of scrape it off, and it's known to be better if this is chamfered a little bit. It's not just a sharp edge. Also, when you're talking about airflow in these areas, because again, these are aligning with ports, when it's at bottom dead center or near that, then airflow does not like very sharp edges. It would prefer a rounded edge, and plus the piston is traveling through the air in the mixture, so again, it shouldn't like this very sharp edge. I don't think there's a whole lot of a gain here, but it's not a bad thing to do. Again, in this case, I'm going to go really, really mild, and I'm just going to try to knock off the sharp edges. So really simple, I'm just putting the soft jaws of my vise to good use, letting it hold it for me. And I'm going to start here. Again, because that line is so close, I'm not taking a whole lot off. I'm just going to try to create a really mild rounded edge there. Here's what it looks like after it's finished. You can see, not aggressive at all, just like I said. Just a little bit of filing, a little bit of sanding, and the main thing is, if you could have felt these before, they felt like they would cut you, a lot of these edges, and now your finger just rolls across them, they're nice and smooth. That should wrap up most of my pre-assembly checks and port matching. I may be forgetting something at the moment, but if I am, I'm sure you'll see it in a future video, so make sure to subscribe. Also, don't forget to clean all of your parts. So that piston that I just did, the cylinder, the cases, make sure everything is very clean and debris free. You should still do a pre-assembly check or pre-assembly cleaning right when you're putting it all together, but it's a good idea to get most of that stuff out of there now so you don't run any risk of introducing aluminum and sanding particles, etc. into your engine. I'm hoping that this video series is helpful for people in many ways. The most obvious being if you're trying to assemble the engine, maybe it'll show you how to do a particular step or whatever you need to do. But something I didn't even really expect so much myself is what I've come across from the unboxing video all the way up to here. So unboxing, we found that there were a bunch of burrs and chips and things, really not quite the level of quality control that I was expecting. So you've got to pay close attention there. And then we found through measurements that even my piston to cylinder clearances weren't exactly on spec from Malossi. I'm not going to do anything about it. It'll be fine the way it is, and I think that's probably pretty normal, but it's just something else that later down the road it might surprise you. If you come up with these wide clearances, you may think your engine's worn out, when it turns out it may be fine. And then you can see from this video, look at the substantial amount of port matching that you've got to do. It's not the kind of thing where you're just going to sit down and match a little bit, you'll be done in a few minutes and you barely got to touch it, just a little filing. You really have to remove some significant material. So there's all sorts of things that I hope you're seeing. You can decide for yourself if you're comfortable doing this stuff or not. If these videos have indeed been helpful for you, please be sure to leave a like, subscribe for more, and share them with anyone else that they may help. As always, thank you for watching.